We'll all come up, we'll take a seat. Nice to see you. Hope we all had a nice cup of coffee. I'm Martin Siegert. I gave that tough sea-level question in the previous panel. So I'm looking forward to receiving some tough questions from you as well. That's what we want. So our session is about the grid, and as you were saying, thinking about an introduction to this, well, just look at the newspaper today and yesterday in the United Kingdom with the wholesale price of gas rocketing 4 times over just a few days. And the consequences of that are utility companies going bust, right? Unable to cope, completely going out of business. So what's the response to that? Is it more cheaper gas, right? Or is it a proper expansion of renewable energy? And if you need that, which I think is absolutely the right way forward, a grid, electric grid, that does the job that we need. That is flexible, that is expansive, that has storage, it's reliable. It's a system that we know we need. It's a system possibly we think we can achieve, but how do we do it, right? And how do we do it at scale, say by 2030? Now that's the challenge for us, and that's what we're going to be talking about. And I'm very pleased to introduce the panel to you. We've got Andrén, who's the Director General of the Swedish Energy Agency, Harald Överholm, the CEO and founder of Alight, and Ulrika, who's the Global VP Customer Solutions, Renewables and Energy Solutions at Shell. Please welcome them with me. And to kick us off, they're each going to talk for a couple of minutes to give you a flavour of what they're thinking about this issue. And I want to give as much time as possible so that we can ask questions. And so that's how this session is going to work. Robert, over to you to start with.
Okay, thank you. And thank you for the invitation to be here. You probably shouldn't have flown over to London with the footprint that it actually creates. But sometimes you also need to meet people because that's where the energy lies. In the meetings. So I've had other meetings as well. On this issue, I think that what we need to understand is that the overarching target, goal, ambition is that we have to stop emitting greenhouse gases, period. Now, how do we do that? By stopping emitting them. That's simple to say, but it of course has a lot of consequences for industry, for society. But I think that what we see today is that industry, during the 18 months we've had now with the pandemic situation, have moved into some kind of leadership when it comes to acting against climate change, doing their bits. Not all industry, but lots of industrial giants, global giants. And I think that the way they have seen is that electrification is one key element to succeed in stopping emitting greenhouse gases. 75% of all greenhouse gas emissions are from energy consumption or production. So if we don't do a proper clean energy transition, we will not be managing to deal with the problem, and we will have very profound and dramatic effects on society. Now, if industry is saying that they will electrify, then I think that the public sector, governments, authorities, agencies such as my agency, has an obligation to see how can we facilitate that movement. And then you need, of course, a toolbox with a lot of tools. And I hope that we can talk about that. Grid is one key thing. It's not the only one, but it's important.
That's what we're talking about today. Please, Harald.
Right.
To you.
Well, thank you. And to follow up on what Robert said, I mean, it's an impact conference. It's all about actions, right? It's all about what actions can we take to make things better. And Martin rightly pointed out that we're seeing, this is a very timely topic about the grids, what's going on, how do we create a resilient grid for the future that is also carbon-free. And I think it was so interesting to see, and picking up on the topic of large companies, big power users, and the actions they can take to actually change this and take it into their own hands. And I mean, 70% of all power is used by companies. So ultimately, if they, as power users, make decisions, that's going to change the grid. That is the way we change the grid. That is the most sustainable engine to drive change. And while we've seen this increasingly in putting more renewable energy online, and big companies through buying power, they enable wind and solar to come online. I think the same thing is going to happen with the solutions to the grid, which is long-term storage, short-term storage, the intelligence around the grid. And it's just the same thing. And if big power users decide to buy that and help developers like ourselves to put that online, it's going to happen. It's going to change the grid, and it's going to create the resilience that would have avoided what we see right now in the UK. Thank you.
Ulrika, from a position company like Shell, what are your opening thoughts about this future?
Yeah, I think, when I accepted to be here today, nobody would have known that we would have had a Black Swan event in the UK with the combination of an interconnector, low wind, and then the increasing global prices of gas. It's not just in the UK. That has caused, all of these challenges in the market today. But with that comes opportunities, I think. So when events like this happen, it also gives the incentives both to governments and private and public companies to step in and lean in and do something about it. From our perspective, so we're of course active in the entire energy value chain here in the UK. UK is, we're Royal Dutch Shell, we're British and Dutch together. And we're extremely committed to the net zero ambition of the UK. We as a company has a net zero target by 2050 or faster in line with society. And I think it's very important to show that all of the things that we can do in order to help this transition. So in the UK, for example, we have invested in a number of companies that are active in both renewable generation, but also in Lime Jump. And Lime Jump is a distributed control system, you can say, where that helps with demand response. So I think the point of reinforcing the grid and have a grid fit for purpose, and I think. My take on that is really that fit for purpose. What does that mean? How can we use distributed energy sources, but how can we also, through digital innovation, actually control when and how we use energy much, much more intelligently? And today only 20% of our energy consumption is electricity. And if we believe any of the projections towards 1.5 degrees, that needs to triple to almost 60%, and that electricity needs to be clean electricity. So I think, taking that challenge of electrification, we're going to need a lot more renewable energy in our systems, and therefore we need a much better system that can manage that intermittency. You talked about short and long-term storage, absolutely, we're currently managing the biggest battery in the world, Minty, which is 100 megawatts. And having that and using that intelligently to help balance the grid when you have events like this is one step forward as well. But there's so many things that we need to do, and I think one of the things that was mentioned also by Robert is collaboration is key. Not one person, one company, one government can solve this. We really need to work together across academia, government, private companies, to come together to come up with the solution for this gigantic problem that we have ahead of us.
Many thanks. Now, do we have any initial questions? Yes, please. I'll come to you in a second.
Thank you very much. My name is Victor Hedenberg from AMBA BGA. My question relates to nuclear energy, which doesn't seem to get as much press as perhaps it should be getting. We talk a lot about, wind, we talk about solar, but these are intermittent energy sources, not 100% reliable, at least. And then if you want to make them reliable, you have to make batteries, and then there are environmental costs to that as well. Not saying nuclear doesn't have it, but how can organizations, governments, even smaller companies learn more about how nuclear power can perhaps be a really great alternative? I mean, if you compare France and Germany, Germany's CO2 levels are way higher than in France, where they use far more nuclear reactors. Not saying there are not risks associated to it, but want to hear your thoughts on this.
Could you give us your name and institution?
AMBA BJ, Victor Hedenberg.
Thank you. Thanks very much. Well, Sweden's got a very good answer for this, and maybe you could...
We talk a lot about it in Sweden, I can tell you. We've done that since the 80s when we had this referendum, you know, where we are saying we should kind of successively take away nuclear from our power energy system. No, I think that you're right. I mean, looking just at the emissions, nuclear power, of course, is fossil-free. But as any other power production, you need to look at the whole life cycle way. So it's the waste treatment, it's the transportation, it's the raw materials you need to produce the energy. And you should also look at the energy losses that are linked to nuclear power production. So I think that, but it's very healthy to discuss this because it will vary in different parts of the world where nuclear power production can actually be something you need to use in order to stop emitting greenhouse gases. But it's not a one-size-fits-all. And I think that renewables has a lot of advantages over nuclear if you look at the whole picture. Offshore wind, for instance, in the UK, as well as in Sweden, of course.
Harald, do you want to?
Right, yeah, look, I can just add something from our side. We're entrepreneurs. That's what we do. We build stuff, we build companies, we build assets. And in order to do that, we just abide by the same laws of nature as everyone else. Like we have to do stuff that makes sense in a financial sense. And nuclear just doesn't fit the bill. I mean, at this point, like I've never seen a credible idea for a startup that would build more nuclear because just the numbers don't check out. So from my point of view, if that's true, and I think that is true, then it's either a political question where you would have to make some very far-reaching political decisions to enable nuclear, or it's simply an academic or a research question where you'd have to invent something new in nuclear in order to make it work. But from what I can tell, it just doesn't work on a commercial basis here and now. You can't build it commercially, and then I think, so it's just not something we would think of, and then we have to focus on what we can build here now, which is solar and wind. I mean, it really works. We can put it online. We can add storage and intelligence to turn it into base load, to turn it into non-intermittent power. We can make that happen here and now because it really does work. I mean, the numbers check out. The technology is simple to build. So I think that is what's driving the energy transition now, and that is the simple reason why nuclear is not really a part of the energy transition at this point. But I mean, all that could very well change if it comes from these other areas, the political or the high tech or the R&D area. I'm sure it could change.
I guess the innovation is going to come in alternative fuels, not using uranium but using thorium. There's plenty more thorium, and it doesn't have some of the problems that uranium does, and it's more controllable as well, and possibly even fusion. Do you have a position on this? Or is it just an open question and you're open-minded about
Well, it's a bit of an open question only because we accredit business schools all over the world, and what we try to do is really couple now business schools to the sciences. Training managers not to just have general management experience, but also knowledge of the sciences and finding some of the practical solutions to these things. And nuclear is one of the things that's coming up in many, let's say, countries where they're discussing this as, okay, is there a way where we can make this more commercially feasible? And thorium is actually a big thing in Indian business schools right now that we're hearing. Of course, massive research going into it at the moment, but of course the innovation isn't there just now.
They're doing a big thorium plant in Switzerland at the moment, but because you need to bombard it with high velocity particles to induce the reactions, which is good because you get a lot of energy when that happens, and good also because if you want to turn it off, you just stop the bombardment. It doesn't runaway reaction doesn't happen with thorium. So we see what happens there. Does Shell have any interest in nuclear power at all?
We've actually taken a decision to not invest in nuclear power generation. But I think, and it's mostly, to your point, Harald, it's less cost effective than combining renewables with batteries and creating baseload through that. If you look at the projects here in the UK, Hinkley C, massively overrun budget, and who knows when it's going to be finished. And then if you look at the Finnish project, which is the other one, 10 years overrun? I mean, massively overrun. So, but it's interesting. I was at a dinner Monday, and there was a very, very heated debate about nuclear, and looking at new technology around nuclear, looking at small nuclear reactor, new materials. But we need that innovation for it to get to the startups and be developed, for it to have a role. And the comparison with France. France did all of this investment in the 50s. And then they're kind of set. Now they're going to face a challenge, and they're heavily investing in renewables today in France, because they see the lifespan of the nuclear reactors also coming to their end, right? But we need innovation, I would say, for it to work.
And we need to get back to grids. So, but thanks for the question. It was very good. You had a question. Did you have a question? Oh, it's just been answered. Any further questions? No. Well, I'll continue with my line of questioning in that case, but please. So we have this problem, and you're quite right, Robert, saying at the beginning, it's an emergency. I'm a glaciologist, told you that before, but the level of CO2 in our atmosphere is at 415 parts per million. That may or may not mean something to you. The last time it was that high, it was about 3.5 million years ago, when the temperature of the planet was about 3 degrees warmer than today, and sea level was 20 meters higher than it is today. So, is that the world that we're inheriting? Is the thermostat, the level of CO2 in the atmosphere? Because if that's the case, then things are going to get bad. We absolutely must hit net zero globally by 2050, and an important part of the solution must surely be electrification, renewable energies, and a grid that's fit for purpose. Get it done really quickly, because I'm told, when I talk to people at Imperial College and others who know about energy and things much more than I do, they say, oh, we've got all these different sectors around the world, transport, retail, manufacturing, all really challenging with this thing. Power sector's pretty sorted though. We know what we're doing, right? We've got a roadmap to electrify the whole thing. Renewables is our friend, grid's gonna do it. There we go. And I'm thinking, well, that's fine. And then, but speaking to Robert over coffee, we were saying, well, actually, probably not going to be able to do this by 2030. What are the problems? What are the pitfalls that are in our way that's stopping acceleration of the progress that we need?
Well, I think that when you talk about the grids, I mean, in Sweden, for instance, taking that as an example, we have a well-built grid, but it's a huge infrastructure. You don't move it from one day to another and just change it. It takes time. And what we have is a debt, a modernization debt in our infrastructure, because we've had no problems with having the electricity that we need, the adequacy in every moment, in every second we've been able to provide the electricity. Today it's different. Today we see a higher urbanization, creating enormous amounts of, the need for electricity increases. So we have a different pattern and a different requirement when it comes to consumption. At the same time, we need to increase our production of electricity, or to meet the new initiatives that we have in Sweden, in the northern parts. We have a battery factory up there, we have a fossil-free steel production that you will hear more about this afternoon. These are huge electrification projects, so we need to produce more electricity. At the same time, we need to kind of replace, within the coming 2 or 3 decades, we need to replace our existing facilities when it comes to electrification, wind power, hydropower, because they are age reasons, technical lifespan. So I think that what we see today, which is a problem if you have a grid that is quite difficult to move from one day to another, is that you have a different consumption and production pattern. And you need to think about both consumption and production when you build and change the grid. But we need to modernize it. But there are innovations.
Well, and it's the innovations I want to come to. So Harald, what are the things? So I hear these imaginative futures where we are utilizing, when people are charging up their phones and their computer batteries and their car batteries, when they're not needed, they can be drawn down by a smart grid that's actually utilizing all the electricity that's out there, rather than generating it from a fresh. How close to that future are we, do you think?
I think we're right there. I mean, as the saying goes, I mean, the future is already here. It's just unevenly distributed among places. And if you look at a place like California, which is arguably the very forefront of technological thinking in the world, at least when it comes to the grid, also of course when it comes to digital stuff. In California now, I mean, we look at, for businesses for example, we look at microgrids that are a combination of solar and storage, and of course intelligence, because it's the intelligence that really makes it, you know, a viable microgrid. And any power user in California, any large power user, a commercial or industrial power user today, with any self-respect, would have or be in the process of installation of one of those microgrids and actually taking a step back from the grid. I mean, they're still using the general grid, of course, but suddenly with much more flexibility and with an ability to provide a significant amount of the power themselves in a reliable way. And this will just continue because you can add more power generation behind the meter, you can add more intelligence, and you can shift your own load as well to fit with that profile that you have. And effectively, in the end, almost disconnect yourself, but not really, but almost disconnect yourself.
Is the answer to that going to be individuals installing something in their homes to make it happen, or it can be done more naturally? Does that has to happen, is it?
Well, the way it's happening in California is that service providers, like Ulrika mentioned, Lime Jump, for example, is someone who's aggregating a lot of these assets, who's servicing them and doing it as a service solution, and very much what we're doing as well. So it's not necessarily, it wouldn't be feasible for everyone to figure out exactly how this is supposed to work and you know, make the whole investment and take the responsibility themselves. Of course, it's going to be an as-a-service solution, but still, I mean, it's something that is done and built. The hardware is installed behind the meter, on the location, is run on the location, and then it's effectively not coordinated with the grid. I mean, you don't particularly have to ask the grid for permission even, or sometimes you need some sort of simple permitting structure, but you don't have to build out the grid for this to happen. Just the opposite, you're actually deloading the grids and making the grids more sustainable.
So is then the solution putting solar panels on that's going to sort of warm the ambient temperature of your water rather than having gas or anything else or renewables take it from a low temperature to a high temperature? Is that the sort of thing that you're thinking about?
So that would be the solar warming bit.
Yes.
Well, of course, I mean, that is one way of doing it, but I think the more general solution across the globe is to just generate power with solar and use that power to deload your reliance on the grid.
I've got a very futuristic question coming up. Are there any other questions? Yeah, my futuristic question is quite a good one, but we'll go. It's the audience participation that we want.
Hi there, I'm Charles from the London School of Economics. Electrification is actually the pathway we chose to meet our net zero carbon targets and decarbonizing our heat systems. I've got a question on, so you've covered demand management, which is really interesting. In terms of supply, if you put the nuclear aside, is there not a land use issue in terms of meeting renewable supply demand in terms of solar and wind? Or is that going to be answered by offshore, or how are we going to manage, especially I'm thinking if agriculture is going to become an issue, then more and more land cannot be used because of climate change. Are we not going to have conflicts of priorities?
It's a very good question. Ulrika, what is sort of Shell's position? Are you looking really offshore for everything, or is it? Or no, we're not. So how then do you tackle the question that actually we could be doing something else with the land that we will be using, either with solar panels or wind farms or whatever?
No, but I think it's a really important question. And if you look at the different types of renewable energy that you can build, you know, of course there's offshore wind, and that's the big, massive, but also takes 10 years to build. It's not, you know, if we decided today, it's not going to start generating until 8 to 10 years from now, right? So we also need a solution today. Solar is one of them, but there's a massive amount of rooftops in the UK and across the globe where we can put solar, so we don't use land. There's also innovation around greenhouses that actually has solar panels in them, so we're growing food while we're also producing electricity. Onshore wind, you farm around it. You know, it takes, yes, the base is maybe, you know, 10 times 10 meters, but around it you can farm. And a lot of, you know, innovation around solar farming as well is to have it as grace for animals. So, you know, and we raise a lot of sheep in the UK, and sheep is perfect to actually have on a solar farm because that removes the need for lawnmowers because you need to keep the grass down, but they actually, and it's a dual purpose use of the land. So I think dual purpose use or triple purpose use of land is what we need to do.
Okay, more questions? Or get my futuristic question if you don't watch out.
Could I have a...
Oh, please, yeah. Oh, yeah, stop me, yeah.
When we talk about energy sometimes, and I think it's marvelous to hear Ulrika saying the ideas that Shell have, which is one of the actors that need to move from where it is at the moment to another place in order for us to be able to deal with the climate change issue. But energy is a market. So you need to have business models that works. So that you actually, I mean, in Sweden we've had this wind power boom, land-based mainly. It's been driven by the market. The equation, the economic equation is there. So when we're talking about these things that we need to try out to find new, perhaps, business models where you need to have investors that actually saying, okay, this is interesting enough, the risk is we can live with this risk, and so on and so forth. I think that is important to keep in mind as well. But I think that's why we need to be much more co-creative between public, private, academia and civil society. But it's nothing that will happen if there is no business model actually attached to it. So we need to find innovative business models that are clean.
Yes, indeed. Okay, I'm going to tell you about the future. Here we go, see if this works. So I was talking to someone quite credible a while back, and they mentioned offshore wind in particular, and they said to me, well, the problem is in the North Sea, as it turns out that we learned this summer, is that it's not always windy. And so what we need to do is find a place where it's always windy. And there is such a place, of course, it's the trade winds. And so what is stopping us, question to you, from putting very large floating offshore wind farms, turbines, offshore of northwest Africa, Morocco, with a very high voltage interconnector across the Strait of Gibraltar and into mainland Europe, giving us, we're not tapping into weather, we're tapping into the rotation of the Earth if we do that. As much energy as you'll ever need, you're not going to stop the Earth spinning. Why? What's stopping us doing that?
Well, getting the actors that we need to come together, to have the same vision, the same target, the same idea. I think it's as simple as that in a way. But then you have
you heard of that before? Is that an idea that you'd heard about?
I've heard similar ideas about putting an enormous cord between Northern Africa and build huge solar panel parks in the desert, more or less, and then you can kind of, Europe doesn't have to think about its own production. But it's I mean, no, but it's about getting the actors together, stakeholders together.
Because what I like about it, from that perspective, from that idea, is that the role of oil and gas companies in 2050 has to be completely different to what it is now. But there's amazing expertise built into these organizations that knows how to do proper, difficult engineering in challenging locations and put infrastructure in place to do it. Isn't this like the role, the future of Shell, for example?
Absolutely.
Have I just described the future of Shell?
Absolutely. No, but it is, you know, there are certain steps that we've taken on the way, right? So floating offshore wind, the technology isn't there today. We invested in a company called Eolfi in France that has a floating wind technology. But we're talking, you know, kilowatts, not megawatts and not gigawatts, because for that we need gigawatts, right? But no, absolutely, you know, large infrastructure projects out in the sea, who's better placed to solve that problem?
Well, time's up, unfortunately, because that was really interesting. I hope you found it interesting as well. Do join me in thanking Robert, Harald and Ulrika for very stimulating and interesting. Thank you also for questions. Thank you. Thank you, Martin.